For over a century, the U.S. aviation industry has been at the forefront of pushing the limits of speed and technology. From the first powered flight by the Wright brothers to breaking the sound barrier with the Bell X-1, American engineers and scientists have constantly worked to make air travel faster, safer, and more efficient. However, one challenge remains unconquered: the ability to fly at hypersonic speeds, meaning speeds faster than Mach 5, 5 times the speed of sound, or over 3,800 miles per hour. At these extreme speeds, a plane could travel from New York to London in less than 90 minutes, a trip that currently takes about 7 hours on a normal airliner. This is not just about flying faster, it's about completely changing the way people and goods move around the world. But reaching hypersonic speed is not easy. The challenges are not just about building a powerful engine. It requires a complete revolution in technology, materials, aerodynamics, and engineering. At such high speeds, air behaves differently, creating intense heat that can destroy an aircraft. Standard jet engines stop working at these speeds, meaning a new type of engine is needed. Even navigating and controlling the plane becomes extremely difficult. This is where Hermes, an ambitious aviation startup, comes in. They are developing the Quarter Horse, a special aircraft that could be the first reusable hypersonic plane in history. Unlike past supersonic jets, such as the Concorde, or military jets like the SR-71 Blackbird, the Quarter Horse is being designed to go beyond Mach 5, making it one of the fastest aircraft ever created. Hermes is not just trying to match past records, they want to shatter them completely. If successful, their technology could change the future of air travel, allowing people to travel between continents in minutes instead of hours. But can this bold vision become reality? Can the Quarter Horse overcome the technical and scientific barriers that have stopped previous hypersonic projects? Today, we take a deep dive into the world of hypersonic aviation, the Quarter Horse, and how Hermes plans to rewrite the future of flight. The dream of faster-than-sound travel has fascinated engineers and scientists for decades. Before hypersonic flight can become a reality, it's important to look back at supersonic aviation, where engineers first broke the sound barrier and pushed the limits of speed. These past achievements lay the foundation for the next big leap: hypersonic travel. Before the mid-20th century, many believed that flying faster than the speed of sound was impossible. Some even thought a plane would break apart if it approached Mach 1, the speed of sound at roughly 767 miles per hour. But in 1947, that myth was shattered when Chuck Yeager, a U.S. Air Force pilot, flew the Bell X-1 rocket plane past Mach 1, becoming the first person to break the sound barrier. This moment was a huge breakthrough, proving that supersonic flight was possible. After Yeager's historic flight, engineers worked hard to develop faster aircraft, leading to the creation of supersonic jets for both military and commercial use. One of the most famous supersonic aircraft was the Concorde, developed by British and French engineers. It was an incredible technological achievement, capable of flying at Mach 2, or twice the speed of regular commercial airplanes. The Concorde allowed passengers to cross the Atlantic in just under 3.5 hours, instead of the usual 7 to 8 hours. Entering commercial service in 1976, it was operated by British Airways and Air France, offering an exclusive experience with ticket prices that cost several times more than a standard first-class fare. The Concorde became a symbol of luxury, speed, and advanced engineering. However, despite its speed, the Concorde faced several major challenges. Operating a supersonic jet required enormous amounts of fuel, making ticket prices very expensive. When an aircraft breaks the sound barrier, it creates a sonic boom, a loud explosive noise that can be heard for miles. Many countries, including the United States, banned supersonic flights over land because of the noise pollution. Because of these bans, the Concorde could only operate over oceans, which restricted its use to specific routes like New York to London or Paris. The aircraft also required constant maintenance, making it costly to operate. In 2000, a Concorde suffered a fatal crash in France, killing all passengers and crew on board. Although the crash was caused by external debris on the runway and not a flaw in the Concorde's design, it severely damaged its reputation. By 2003, after nearly 30 years of service, the Concorde was retired. Its legacy remained, but it also highlighted the challenges of supersonic travel, particularly the balance between speed, cost, and efficiency. While the Concorde was a civilian aircraft, military aviation had already been pushing the boundaries of speed for years. One of the most famous supersonic planes was the SR-71 Blackbird, a reconnaissance aircraft developed by Lockheed Martin. The SR-71 Blackbird could fly at Mach 3.3, making it the fastest jet ever built. Its speed allowed it to outrun enemy missiles, and it was used for high-altitude surveillance missions during the Cold War. Despite its incredible capabilities, the SR-71 also had limitations, such as high fuel consumption, extreme heat buildup, and costly maintenance. Other military jets, like the F-22 Raptor and F-35 Lightning II, are designed for supersonic speeds, but they primarily focus on maneuverability and stealth rather than extreme speed. This is because flying at high speeds for extended periods generates intense heat and requires special materials that can withstand the stress. The Concorde and SR-71 Blackbird were both revolutionary aircraft, but they also exposed the challenges of high-speed flight. The Concorde proved that speed alone is not enough. It was fast, but too expensive and too restricted to be widely used. Future hypersonic aircraft need to be more efficient and affordable to succeed. The SR-71 faced extreme heating issues due to air friction at high speeds. Hypersonic planes will need advanced cooling systems and materials that can withstand temperatures over 2,000 degrees Fahrenheit. Traditional jet engines can only operate up to a certain speed before they become inefficient. This is why Hermes is developing Chimera, a hybrid engine that transitions between turbojet, ramjet, and scramjet modes. Governments also place restrictions on supersonic and hypersonic travel due to sonic booms, safety concerns, and airspace regulations. For hypersonic planes to become mainstream, these challenges will need to be addressed. With the lessons of supersonic aviation in mind, the next goal is hypersonic flight, reaching speeds of Mach 5 and beyond. Unlike supersonic jets, hypersonic aircraft will need to use revolutionary engine technology to handle different speeds efficiently, develop new materials that can withstand extreme heat, and create solutions for noise reduction to make high-speed travel over land possible. This is where Hermes and the quarter horse come in. Learning from past mistakes, Hermes aims to succeed where others failed, bringing us closer than ever to a world where hypersonic travel is a reality. But can they overcome the barriers that held back the Concorde and the SR-71? Will hypersonic planes become commercially viable, or will they remain a dream limited to military applications? In the next section, we explore the quarter horse, a plane that could change everything we know about high-speed flight. As hypersonic flight becomes the next frontier in aviation, one aircraft is leading the charge: the quarter horse, an advanced hypersonic vehicle designed to reach speeds beyond Mach 5. Developed by Hermes, this aircraft is not just a new addition to the world of high-speed aviation. It's a revolutionary step toward a future where hypersonic travel is not only possible, but also practical and reusable. Unlike past supersonic jets that struggled with efficiency and operational costs, the quarter horse is built with cutting-edge technology that aims to break old speed records while solving the fundamental challenges of hypersonic flight. Hermes isn't just building another experimental aircraft, they are reimagining what flight can be. The goal is to create a fully autonomous, reusable hypersonic aircraft that can be used for both military and commercial applications. If successful, quarter horse could be the first step toward hypersonic passenger travel, shrinking long-haul flights from hours to mere minutes. But making hypersonic flight a reality requires solving some of the most difficult engineering problems in aviation history. The biggest challenges include extreme heat, engine efficiency, and control at hypersonic speeds. At speeds beyond Mach 5, the friction between the aircraft and the air generates enormous amounts of heat, enough to melt conventional aircraft materials. This means every part of the quarter horse, from its structure to its propulsion system, must be designed to withstand conditions that would destroy normal jets. One of the most impressive aspects of the quarter horse is its turbine-based combined cycle TBCC propulsion system, known as Chimera. Unlike traditional jet engines, which become inefficient at higher speeds, Chimera combines 3 different types of engines, turbojet, ramjet, and scramjet, into a single integrated system, This allows quarter horse to take off like a regular jet, then switch to ramjet and scramjet propulsion as it reaches higher speeds. Each engine type serves a critical purpose in different phases of flight. Turbojet engine, used during takeoff and early acceleration, capable of functioning up to around Mach 2. Ramjet engine, activates once the aircraft reaches Mach 2 to Mach 3, using the aircraft's own speed to compress incoming air instead of relying on rotating compressors like traditional jet engines. Scramjet engine, takes over beyond Mach 5, allowing the aircraft to sustain hypersonic speeds without needing moving parts like turbine blades. This combination gives quarter horse the ability to operate efficiently across a wide range of speeds, solving one of the biggest problems that held back previous high-speed aircraft. While many hypersonic projects have been abandoned due to engine limitations, quarter horse's Chimera propulsion system is designed to handle the entire speed range seamlessly. But making an engine that can transition between these modes is incredibly difficult. The ability to switch between turbojet, ramjet, and scramjet propulsion at the right time, without disrupting airflow, fuel delivery, or aircraft stability, has been a major challenge in hypersonic research for decades. In November 2022, Hermes successfully demonstrated the transition from turbojet to ramjet propulsion, a huge milestone proving that their concept is not just theory, but a working reality. Aside from its advanced engine system, quarter horse is also designed to be reusable, a critical feature for making hypersonic travel practical. Past hypersonic test vehicles, like NASA's X-43 and X-51 Waverider, were designed for one-time use, meaning they could only fly once before being discarded. This made hypersonic research expensive and inefficient. Quarter horse, however, is being built as a fully reusable vehicle, allowing multiple test flights without having to build a new aircraft every time. This not only lowers costs, but also speeds up the development process, allowing engineers to test and refine the technology much faster than before. Quarter horse's speed and advanced propulsion system make it an ideal candidate for military applications, such as high-speed reconnaissance and rapid strike missions. In combat situations, the ability to reach any point on the globe in under an hour would provide an unmatched strategic advantage. If equipped with sensors or weapons, a hypersonic aircraft like quarter horse could evade enemy defenses with sheer speed alone, much like the SR-71 Blackbird, but at more than twice the speed. However, Hermes is not just focusing on military applications. Their long-term vision is to make hypersonic travel available to the commercial sector, opening the door to passenger flights that cross the world in a fraction of the time it takes today. Imagine flying from New York to Tokyo in just 2 hours, or traveling from Los Angeles to Sydney in under 3 hours. Quarter horse is the first step toward making this vision a reality. Despite the excitement surrounding the quarter horse, there are still many hurdles to overcome before hypersonic travel can become mainstream. The biggest challenges include thermal management, as the aircraft will experience extreme heating due to air friction at hypersonic speeds. Current aircraft materials cannot survive at these temperatures for extended periods, so engineers must develop new heat-resistant materials that can withstand over 2,000 degrees Fahrenheit or 1,100 degrees Celsius without degrading. Another major challenge is fuel efficiency. Hypersonic aircraft burn fuel at a much higher rate than normal jets, and there is currently no widely available fuel source that can provide the necessary energy-to-weight ratio while maintaining efficiency at high speeds. To solve this, Hermes is exploring advanced fuel technologies, including hydrocarbon-based fuels and alternative energy sources, to ensure that hypersonic travel can be both practical and environmentally sustainable. One of the most difficult barriers to widespread hypersonic travel is airspace regulation. Today, many countries have strict rules about supersonic and hypersonic travel over land due to the impact of sonic booms. A hypersonic plane traveling at Mach 5 would produce a shock wave so powerful that it could shatter windows and damage structures on the ground. To make hypersonic commercial travel a reality, Hermes will need to work closely with governments and aviation regulators to develop solutions that minimize or eliminate these effects, such as sonic boom mitigation technology. Despite these challenges, Hermes is moving faster than any previous hypersonic project. Their development timeline is ambitious, with the first quarter horse flight tests expected in the next 2 years. If successful, this aircraft could mark the beginning of a new era in aviation, one where distances no longer matter and the world is more connected than ever before. With a team of former SpaceX Blue Origin and US Air Force engineers, Hermes is positioned to achieve what was once thought to be impossible. The quarter horse is more than just an aircraft. It's a proof of concept that hypersonic travel is within reach. If all goes according to plan, the world may soon witness the fastest and most advanced aircraft in history, setting the stage for hypersonic transport to become a real, everyday part of our future. The road ahead is challenging, but with each successful test, Hermes moves one step closer to proving that the age of hypersonic travel has arrived. But can they truly push past the barriers that have stopped others before them? Will the quarter horse be the aircraft that finally breaks through and brings hypersonic travel to the mainstream? In the next section, we explore the Chimera engine, the revolutionary technology that powers the quarter horse and could change aviation forever. At the heart of the quarter horse's hypersonic ambitions lies one of the most advanced propulsion systems ever developed, the Chimera engine. Unlike traditional jet engines that have powered aircraft for the past century, Chimera is designed to operate efficiently at speeds from takeoff to Mach 5 and beyond, a feat that no single engine has ever achieved. To accomplish this, Hermes has developed a turbine-based combined cycle, TBCC engine, which seamlessly integrates turbojet, ramjet, and scramjet technologies into one system. This engine is not just a step forward in aviation, it represents a fundamental shift in how we think about high-speed flight. The biggest challenge in hypersonic flight is not just achieving Mach 5, it's sustaining those speeds over long distances while maintaining efficiency and control. Traditional jet engines, like those found in commercial airliners, can only function up to about Mach 2 before they become inefficient. Ramjets and scramjets, on the other hand, are optimized for high speeds but cannot operate at low speeds. This has been a major roadblock in hypersonic aviation for decades. The Chimera engine solves this problem by using different propulsion modes at different speeds, automatically transitioning between them as the aircraft accelerates. Turbojet mode, takeoff to Mach 2. At low speeds, the quarter horse relies on a turbojet engine, similar to those used in fighter jets. Turbojet engines are effective for takeoff, low-speed cruising, and initial acceleration because they use rotating blades to compress incoming air before combustion. However, turbojets become inefficient at speeds beyond Mach 2, where air resistance increases dramatically. At this point, Chimera transitions into its next phase, ramjet mode, Mach 2 to Mach 5. Once the aircraft reaches around Mach 2, the Chimera engine switches to ramjet mode. Unlike a turbojet, a ramjet has no moving parts. Instead, it relies on the aircraft's own speed to compress the incoming air before combustion. This allows it to generate more thrust with less complexity, making it perfect for high-speed travel. Ramjets work well between Mach 2 and Mach 5, but beyond this range, even they start to lose efficiency. This is where the scramjet comes in. Scramjet mode, Mach 5+. At speeds beyond Mach 5, the Chimera engine enters its final phase, scramjet propulsion. A scramjet, supersonic combustion ramjet, works similarly to a ramjet but is specifically designed to operate at hypersonic speeds. Unlike a ramjet, which slows incoming air to subsonic speeds before combustion, a scramjet allows the airflow to remain supersonic, greatly increasing efficiency. Scramjets have long been considered the key to sustained hypersonic flight, but transitioning between different propulsion systems in a single aircraft has never been successfully achieved, until now. One of the most challenging aspects of designing the Chimera engine was making these transitions smooth and reliable. Switching from turbojet to ramjet to scramjet must be done seamlessly, without interruptions in airflow or power output. Any disruption could cause engine failure, loss of control, or catastrophic failure of the aircraft. Hermes has spent years refining the technology, and in November 2022, they successfully demonstrated the transition from turbojet to ramjet, a huge milestone in hypersonic engine development. But even with this breakthrough, Chimera 1 is just the first step. Hermes is already working on Chimera 2, the next generation version of the engine, which will be based on the Pratt & Whitney F-100. the same engine used in the F-15 Eagle and F-16 Fighting Falcon fighter jets. The F-100 is known for its powerful and durable design, capable of sustaining speeds of Mach 2.5 while operating under extreme conditions. By integrating this engine into Chimera II, Hermes aims to increase power output, efficiency, and reliability, bringing them even closer to making reusable hypersonic flight a reality. Chimera II will improve on several critical areas that are necessary for sustained hypersonic operations. Improved heat resistance. At Mach 5+, aircraft surfaces can reach temperatures of over 2,000 degrees Fahrenheit, 1,100 degrees Celsius, due to air friction. Chimera II will incorporate advanced heat-resistant materials and cooling systems to prevent overheating and maintain stability. Enhanced fuel efficiency. Hypersonic engines burn fuel at an extremely high rate, which has been a major challenge in making hypersonic travel practical. Chimera II will optimize fuel injection and combustion efficiency, reducing fuel consumption while maintaining high thrust output. Seamless engine transitions. The next-generation system will further refine the switching process between propulsion modes, ensuring smoother operation and eliminating the risk of mid-flight failures. One of the biggest challenges in hypersonic flight is keeping the engine from melting itself. At extreme speeds, the inside of a scramjet engine experiences intense pressure and heat, which can weaken materials, damage components, and reduce efficiency. To counter this, Hermes is developing advanced cooling techniques, including active thermal management systems that circulate cool air through the engine to prevent overheating. Another major improvement in Chimera II is its integration with the quarter horse's advanced flight control system. At hypersonic speeds, even the smallest changes in air pressure, temperature, or fuel flow can affect the aircraft's performance. Chimera II will use AI-driven sensors and adaptive control algorithms to constantly monitor and adjust engine performance in real time. This will allow the aircraft to respond dynamically to changes in altitude, speed, and atmospheric conditions, ensuring optimal efficiency and stability throughout the flight. Hermes is also exploring the use of alternative fuels, such as high-energy hydrocarbon-based fuels and sustainable aviation fuels, SAFs, to improve energy efficiency and reduce environmental impact. While hypersonic engines require high-density fuel sources to sustain their power output, advancements in fuel chemistry and injection technology could make future hypersonic aircraft both faster and more sustainable. Beyond military and commercial applications, the Chimera engine represents a major leap forward in reusable hypersonic technology. Unlike previous hypersonic vehicles, such as NASA's X-43 and the US Air Force's X-51 Waverider, which were single-use experimental aircraft, Quarter Horse and Chimera are designed to be flown repeatedly. This will dramatically reduce costs and increase the pace of hypersonic research, allowing engineers to rapidly test and refine the technology in real-world conditions. With Chimera II set to debut in the next-generation Quarter Horse Mk2 and Mk3 prototypes, Hermes is positioning itself at the forefront of the hypersonic revolution. If successful, their TBCC-powered aircraft could become the first fully operational, reusable hypersonic system in history. The road ahead is still filled with challenges, but with each new development, Hermes is proving that the dream of routine hypersonic travel is closer than ever before. The Chimera engine is more than just a technological breakthrough. It's the key to unlocking the future of high-speed aviation. With upcoming test flights and continued advancements in engine efficiency, heat resistance, and reusability, we may soon see a world where flying across the planet in under 2 hours is not just a fantasy, but an everyday reality. The next step in this journey is seeing how Hermes plans to scale its technology beyond experimental aircraft. In the next section, we explore the larger vision for Hermes and how the Quarter Horse is paving the way for full-scale hypersonic passenger travel. Hypersonic technology has long been seen as the domain of military research, with projects focusing on missile systems, reconnaissance aircraft, and rapid strike capabilities. The ability to travel at Mach 5 and beyond gives military forces an unmatched speed advantage, allowing them to outpace enemy defenses, conduct deep penetration surveillance, and strike high-value targets before an adversary can react. But Hermes is not just another defense contractor building hypersonic weapons. While the quarter-horse and Chimera engine technology have undeniable military value, the true vision of Hermes extends far beyond combat applications. Their ultimate goal is to bring hypersonic flight into the commercial world, revolutionizing air travel, global logistics, and scientific research in ways never before possible. A revolution in air travel. Since the days of the Concorde, the dream of high-speed passenger travel has remained alive, but no company has been able to make it practical. The Concorde was fast, but it was also incredibly expensive, noisy, and fuel-hungry, making it accessible only to the ultra-wealthy. Regulatory restrictions on supersonic booms prevented it from flying over land, limiting it to a handful of transatlantic routes. Hermes aims to solve these problems, creating a hypersonic passenger jet that is not only fast but also affordable, fuel-efficient, and widely usable. Their planned hypersonic passenger aircraft, currently codenamed Halion, would travel at speeds of Mach 5, reducing flight times by more than 80%. A trip from Los Angeles to Tokyo, which currently takes over 11 hours, could be completed in just under 2 hours. Such an advancement would completely change the way people think about air travel. Instead of spending an entire day flying across the globe, business executives, tourists, and even everyday travelers could reach their destinations in the same amount of time it takes to watch a movie. This would create a world where long-distance travel is no longer a hassle but an everyday convenience. However, there are several key challenges that must be overcome to make commercial hypersonic travel a reality. Regulatory barriers. Governments currently restrict supersonic and hypersonic flight over land due to the sonic boom problem. Hermes is working on next-generation aerodynamic designs that can minimize or eliminate these booms, potentially making overland hypersonic flight legally viable. Infrastructure adaptation. Hypersonic aircraft will require specialized runways, fueling stations, and air traffic control procedures to ensure safe operations. This means airports and airlines will need to upgrade their systems before hypersonic travel can be integrated into commercial aviation. Cost and accessibility. For hypersonic travel to truly change global transportation, it must be affordable. Hermes is focused on reusable technology and fuel-efficient designs to bring down costs, making hypersonic tickets more accessible to the general public. Transforming global logistics. The ability to transport cargo at hypersonic speeds would create an entirely new economy based on instantaneous global delivery. Today, companies like FedEx, UPS, and Amazon rely on a combination of air and ground transport, meaning international shipments take days or even weeks to arrive. A hypersonic cargo jet could shrink that time frame to just hours. For example, imagine a world where medical supplies can be flown from one side of the world to the other in under 3 hours, helping save lives during emergencies. Perishable goods, such as fresh seafood or vaccines, can be delivered the same day to anywhere on the planet. High-value electronics and critical components can be shipped instantly, eliminating costly delays in global supply chains. These advancements wouldn't just make logistics faster, they would also transform industries by allowing businesses to operate on a truly global scale without worrying about shipping delays. Space travel and scientific research. Hypersonic technology is also expected to play a major role in the future of space exploration. Currently, launching payloads into orbit requires expensive single-use rocket boosters that cost millions of dollars per launch. Hermes's reusable hypersonic engine technology could eventually lead to space planes that replace traditional rockets, making space travel more cost-effective and accessible. Some potential applications of hypersonic technology in space exploration include suborbital space tourism. Hypersonic spaceplanes could make commercial space travel a reality, allowing ordinary people to experience the edge of space without requiring massive rockets. Rapid satellite deployment. Instead of waiting weeks for a launch window, hypersonic aircraft could deploy satellites on demand, allowing real-time upgrades to communication and navigation networks. Deep space exploration. The same technologies being developed for high-speed flight on Earth could also be used for fast-traveling spacecraft, shortening the time required for missions to the Moon, Mars, and beyond. Hypersonic search and rescue operations. In emergency situations, time is the most valuable resource. Whether it's a natural disaster, military crisis, or medical emergency, hypersonic aircraft could deliver aid, personnel, and equipment faster than any existing method. Imagine a scenario where a remote island is hit by a powerful hurricane. With current technology, it could take 24 to 48 hours for emergency relief teams to arrive. A hypersonic rescue aircraft could deliver supplies and medical teams in under 2 hours, dramatically improving survival rates and reducing damage. Similarly, military and intelligence agencies could use hypersonic aircraft for rapid deployment of special forces, high-speed reconnaissance, or urgent evacuations from dangerous conflict zones. The timeline for hypersonic commercialization. Unlike past projects that stalled due to technological and financial limitations, Hermes is aggressively working toward a commercially viable hypersonic aircraft within the next 10 to 15 years. Their development roadmap includes 2024 to 2026, extensive testing of the quarter-horse Mk1 and Mk2 prototypes, proving the viability of reusable hypersonic flight. 2027 to 2030, scaling up to larger aircraft, testing commercial fuel efficiency, noise reduction technologies, and regulatory compliance. 2031 to 2035, introduction of the first commercial hypersonic cargo and passenger flights, bringing hypersonic travel to global markets. If Hermes succeeds, the world will enter an entirely new era of transportation. The barriers of distance and time will be shattered, allowing people and goods to move across the planet faster than ever before. Hypersonic travel will no longer be a concept reserved for military projects. It will become an everyday reality for business, logistics, and even personal travel. However, the road ahead is far from easy. The company must still prove that its technology is safe, affordable, and practical for commercial use. It must also navigate the complex regulatory environment and ensure that its aircraft meet strict environmental and noise pollution standards. But if there's one thing history has shown, it's that aviation thrives on breakthroughs. The Wright brothers were told that powered flight was impossible. Engineers who built the Concorde were doubted at every turn. Yet each time, innovation pushed humanity forward. Hypersonic flight is the next great leap, and Hermes is determined to lead the way. Their work on Quarter-Horse, Chimera, and Halion could redefine how we travel, how we do business, and how we connect with the world. In the next section, we take a closer look at the future of Hermes aircraft, including Quarter-Horse's next test phases and how the company plans to transition from experimental hypersonic prototypes to full-scale commercial jets. Reaching Mach 5 is more than just about speed. It represents the next great leap in aerospace technology, a milestone that will redefine military strategy, commercial travel, and even space exploration. But getting there is an enormous challenge. Hypersonic flight is not simply a matter of pushing an aircraft to fly faster. It requires an entirely new way of thinking about aerodynamics, propulsion, heat management, and materials science. Hermes is racing to solve these challenges, developing Quarter-Horse as the world's first reusable hypersonic aircraft. Their goal is to go beyond theoretical research and short-lived prototypes. They want to build an aircraft that can fly at hypersonic speeds again and again, proving that sustained Mach 5 plus travel is not just possible, but practical. This journey is divided into several key phases, each designed to push the limits of technology and bring hypersonic flight closer to reality. Hermes began its hypersonic journey with Quarter-Horse Mk0, the ground-based test vehicle designed to validate key systems before moving to flight. In early 2024, Mk0 successfully completed remote control and RF latency testing, ensuring precise handling and responsiveness at high speeds. Ground propulsion tests, simulating the transition from turbojet to ramjet engines. Flight control verification, testing the onboard AI-driven adaptive control system that will allow Quarter-Horse to make real-time adjustments mid-flight. With these tests completed, Hermes is now moving to Quarter-Horse Mk1, the first flight-ready prototype, scheduled to take off from Edwards Air Force Base by late 2024. This version will be a scaled-down but fully functional model designed to conduct high-speed takeoff and landing tests, validate the Chimera engine's ability to operate at sustained supersonic speeds, Test initial turbojet to ramjet transition capabilities in a controlled flight environment. These tests will prove whether quarter horse's unique propulsion system can transition between different flight modes without stalling or losing stability, one of the biggest technical challenges in hypersonic aviation. Once the Mk1 tests are completed, Hermes will introduce quarter horse Mk2, the first full-scale aircraft capable of sustained supersonic and hypersonic speeds. Unlike Mk1, which is primarily a testbed for takeoff and landing, Mk2 will push far beyond Mach 3, bringing Hermes closer to breaking the SR-71 Blackbird's long-standing speed record. Quarter horse Mk2 will feature the upgraded Chimera 2 engine based on the Pratt & Whitney F100, allowing longer sustained high-speed cruising at Mach 3+. Advanced heat-resistant materials capable of withstanding extreme friction and temperatures above 2,000 degrees Fahrenheit, 1,100 degrees Celsius. Improved fuel injection and energy efficiency, reducing overall fuel consumption while maintaining high thrust output. Mk2 will be the first Hermes aircraft to attempt extended high-speed flight at Mach 3 and beyond. Mid-air engine transitions, switching between turbojet, ramjet, and scramjet modes during a single flight. Sustained flight endurance testing, proving that a hypersonic aircraft can function over long distances rather than just short bursts. If successful, Mk2 will set the foundation for real-world hypersonic operations, proving that sustained Mach 3 plus flight is possible with a reusable engine system. The biggest challenge in hypersonic aviation is not getting to Mach 5, but staying there. Most experimental hypersonic vehicles, like NASA's X-43A or the US Air Force's X-51 Waverider, were single-use test vehicles that achieved hypersonic speeds for just a few minutes before burning up or crashing into the ocean. Hermes wants to change this. Quarter horse Mk3 will be the first fully reusable aircraft designed to cruise at Mach 5 for extended periods. This version will incorporate active cooling technology to prevent overheating at extreme speeds, a reinforced airframe made from ultra-lightweight, heat-resistant alloys, optimized engine transitions, allowing for seamless switching between ramjet and scramjet modes without disruptions, breaking the SR-71 speed record, aiming for a sustained cruise at Mach 4+, sonic boom mitigation testing, using aerodynamic shaping to reduce noise pollution and make hypersonic flight over land more viable. Extreme endurance flights proving that a hypersonic aircraft can maintain speed for over an hour without failure. If Mk3 succeeds, it will be the fastest aircraft in history, surpassing the SR-71, the Concorde, and every other jet that came before it. While Quarter Horse is a test platform, the ultimate goal is to develop a commercial hypersonic passenger jet, codenamed Halion. This aircraft will be 5 times faster than today's commercial jets, cutting transoceanic flight times by over 80%. Designed for overland travel, using sonic boom reduction technology to fly at Mach 5+ without violating airspace restrictions. Capable of operating from major international airports, integrating into existing air travel networks with minimal modifications. By 2030, Hermes plans to launch the first commercial test flights, beginning with cargo transport before transitioning to passenger services by 2035. Even with rapid technological progress, several key challenges must still be solved before hypersonic flight becomes mainstream. Fuel efficiency. Hypersonic engines burn fuel at an extreme rate, requiring new fuel types or more efficient combustion methods. Hermes is exploring high-energy hydrocarbon fuels and sustainable aviation fuels (SAFs) to optimize performance. Heat management. At Mach 5, aircraft surfaces experience intense air friction, requiring new materials and cooling techniques to prevent overheating and structural failure. Hermes is pioneering active cooling systems and advanced ceramic composites to tackle this issue. Regulatory approval. Hypersonic travel will require changes to international airspace laws, as current regulations do not allow sustained overland hypersonic flights. Hermes is working with NASA, the FAA, and international aviation authorities to ensure a smooth regulatory transition. Affordability and accessibility. Supersonic travel was historically too expensive for mainstream use. Hermes is focused on cost-efficient, reusable aircraft that will make hypersonic flight affordable for commercial and cargo transport alike. Hermes is not just building a faster aircraft. They are laying the foundation for an entirely new era of transportation. The quarter-horse project is proving that reusable hypersonic aircraft are not just possible but practical, scalable, and inevitable. If they succeed, the barriers of time and distance will collapse. Business trips between New York and Tokyo will take 90 minutes. Cargo shipments that currently take days will arrive within hours. The dream of space planes and intercontinental hypersonic networks will move from science fiction to everyday reality. In the next section, we explore the final hurdles and what the future of Hermes and hypersonic flight looks like in the years ahead. Hypersonic travel is no longer a dream. It is an inevitable evolution in aviation that will redefine how humans move across the planet. For decades, the pursuit of faster-than-sound flight was hindered by technological, regulatory, and economic challenges. But with the rise of Hermes and its revolutionary hypersonic quarter-horse program, the world is now on the verge of entering the hypersonic age. With speeds surpassing Mach 5, hypersonic travel will not only revolutionize military and commercial aviation, but also transform global commerce, space exploration, and scientific research. The next few decades will be marked by rapid advancements in propulsion, materials, and airspace regulations, paving the way for a future where flying anywhere in the world takes less time than a morning commute. How hypersonic travel will reshape the world. If Hermes and other aerospace innovators succeed in creating efficient, reusable, and commercially viable hypersonic aircraft, the world will experience an era of unprecedented global connectivity. Every major industry, from business and logistics to healthcare and tourism, will undergo a massive transformation. Commercial air travel today is slow and inefficient compared to modern technological capabilities. Despite advances in aircraft design, flight times have remained largely unchanged for over 50 years. A flight from New York to London still takes nearly 7 hours, and intercontinental routes like Los Angeles to Sydney require over 15 hours in the air. With hypersonic travel, those numbers would be slashed dramatically. New York to London, 90 minutes instead of 7 hours. Los Angeles to Tokyo, 2 hours instead of 11 hours. Dubai to New York, 2.5 hours instead of 14 hours. This means passengers could fly across the world and return on the same day. Business trips that currently require multiple days of travel could be completed within a few hours, making global commerce more efficient and seamless. Additionally, hypersonic travel could open up new tourism possibilities, allowing people to visit distant locations without the burden of long-haul flights and jet lag. However, the road to hypersonic passenger flights is not without challenges. The biggest hurdles include noise regulations. The sonic boom of a Mach 5 plus aircraft could cause disturbances over populated areas, necessitating new aircraft designs to minimize noise pollution. Safety concerns. Hypersonic flight introduces new risks, such as intense heating, rapid pressure changes, and extreme aerodynamic forces, all of which must be mitigated through rigorous testing and technological innovations. Infrastructure. Most existing airports are not equipped to handle hypersonic aircraft, meaning major upgrades in runways, air traffic control, and fueling systems will be necessary. Despite these challenges, many leading aerospace companies, including Hermes, NASA, and Boeing, are working on next-generation designs that will make hypersonic passenger travel a reality within the next 10 to 20 years. Beyond passenger travel, one of the most immediate impacts of hypersonic flight will be in global logistics and cargo transport. Today, international shipping relies on a combination of commercial air freight, cargo ships, and trucking networks, all of which are slow, expensive, and inefficient. With a fleet of hypersonic cargo aircraft, companies like Amazon, FedEx, and UPS could deliver goods anywhere in the world within hours, revolutionizing industries such as e-commerce. Online retailers could offer same-day international delivery, eliminating long wait times for customers ordering products from overseas. Pharmaceuticals. Hypersonic aircraft could rapidly transport vaccines, medicines, and medical supplies to regions experiencing health crises. Fresh food and perishables. Perishable goods, such as seafood, meats, and fruits, could be transported at record speeds, expanding access to fresh food worldwide. Disaster relief and emergency response. Humanitarian aid could be delivered instantly to disaster zones, helping communities recover more quickly from earthquakes, hurricanes, or other natural catastrophes. The introduction of hypersonic cargo planes could also reduce the need for traditional, long-haul trucking and slow-moving cargo ships, making supply chains faster, more efficient, and more environmentally friendly. Hypersonic flight and the future of space exploration. One of the most exciting applications of hypersonic technology lies in space exploration. Traditional rocket launches are incredibly expensive and require extensive preparation, limiting access to space for all but a few organizations. Hypersonic spaceplanes could provide a game-changing alternative. Instead of using massive, disposable rockets, a reusable hypersonic aircraft could take off from a runway, accelerate to Mach 5+, and then transition into space, delivering satellites, supplies, or even astronauts at a fraction of the cost of traditional spaceflight. Some potential uses include rapid satellite deployment. Hypersonic spaceplanes could launch satellites on demand rather than waiting for costly rocket launches. Suborbital space tourism. Commercial companies like Blue Origin and SpaceX are already exploring suborbital flights for tourists, and hypersonic spaceplanes could expand this industry even further. Lunar and Mars exploration. Hypersonic aircraft could serve as test beds for the future of interplanetary travel, developing the propulsion systems needed for high-speed missions to Mars and beyond. If Hermes succeeds in building scalable, reusable hypersonic aircraft, the future of space travel could become far more accessible and cost-effective than ever before. Despite the immense promise of hypersonic technology, several challenges must still be addressed before it can become a practical reality. Extreme heat and structural integrity. At speeds above Mach 5, the surface of a hypersonic aircraft experiences intense air friction, causing temperatures to exceed 2,000 degrees Fahrenheit, 1,100 degrees Celsius. Special heat-resistant materials, advanced cooling systems, and reinforced structural designs are needed to prevent the aircraft from melting or disintegrating mid-flight. Fuel efficiency and environmental impact. Current jet fuels are not optimized for hypersonic speeds, requiring new types of high-energy fuels that can sustain long-duration hypersonic travel while minimizing carbon emissions. Sustainable aviation fuels, SAFs, and new hydrocarbon fuel blends could be key to solving this issue. Regulatory and air traffic control challenges. Existing air traffic control systems are not designed to handle aircraft traveling at hypersonic speeds. New regulations must be created to ensure safe airspace coordination, prevent collisions, and manage hypersonic air traffic effectively. Public perception and market adoption. For hypersonic travel to succeed commercially, it must be safe, reliable, and affordable. The public must be willing to embrace new forms of high-speed travel, and airlines must see a viable business model that justifies investment in hypersonic fleets. The next decade will be a defining period for hypersonic travel. Companies like Hermes, NASA, and SpaceX are investing billions of dollars into developing the next generation of hypersonic aircraft, propulsion systems, and infrastructure. If Hermes succeeds in scaling its quarter-horse project into commercial operations, the way we think about distance and time will change forever. A new age of transportation will emerge, where people can travel across the world in minutes. Cargo can be delivered instantly, and access to space will become as routine as flying across the country. The race to Mach 5 and beyond has begun. The question is no longer if hypersonic travel will become a reality, but when. What do you think? Will hypersonic aircraft become the new standard, or are we still decades away from a true breakthrough? Let us know in the comments below. And don't forget to like, subscribe, and stay tuned for the next chapter in the story of aviation. Blast off.